What's going on, everybody? Mr. Diamond, and these are going to be the example problems for molecular naming. And as you are going to notice, they are much easier than the ionic one. They don't ever really get difficult. The hardest part about any of them are the prefixes can be a little tough. But if you feel like you're okay at the ionic compounds, these should be an absolute cakewalk. So first, we can tell that all of these are molecular because their first elements are all non-metals that are not hydrogen. C2, that's a carbon. Carbon is a nonmetal. B is boron, that's a nonmetal. P is phosphorus, that's a nonmetal. So we're going to do our same kind of approach that we did before. We're going to name the first piece, adding a prefix if needed. So this one is carbon, and it's got two of them, so we need to represent that it's two. And because there's no crossing our charges or anything like that that we would do to predict that there are two carbons involved in this, we have to say exactly in the name, it is dicarbon. Then we look at the second piece and we say what name goes with 4. 4 is tetra. And then it's oxygen, so tetroxygen, well, we need to change the ending because it's the second piece. Remember, all of the second pieces for all of our ionic compounds need to have IDE, so we can tell that it's connected to this first piece. So it must be so tetra, and then it'll be tetroxide. Tetra from 4, you could have also done tetraoxide. I would have counted that, but it's technically the way that chemists prefer to write it is tetroxide. Tetra meaning 4, ox telling you that it's oxygen, ide telling you that it's attached to this first piece. So dicarbon tetroxide would be C2O4. Okay, next example, we have B, which is boron, and since there's no number, we don't need to add anything. So we've got boron. Again, I'm going to separate this apart. And then we look at the second piece. That's F, which is fluorine, but there are 8 of them. So that would be octa, and then fluoride, because again, we changed the ending to IDE. So BF8. There's one boron because there's no number out front. It's attached to, which we know because of the IDE, a fluorine, and there are 8 of those. So it's octa. Boron, octa, fluoride. Right, last example of going from formula to name. We have 5 P's, and P is phosphorus. So it'll be pentaphosphorus. And then we've got 10 O's. So in this case, 10 is dec. So it's decoxide. Again, we changed the ending to IDE to let you know that it's attached to the piece that's before it. Now, I wrote these separated from each other, but that's just because I'm trying to be paper efficient and not kill a whole lot of trees. But really, you would write this in one row. C2O4 is dicarbon tetroxide. BF8 is boron octafluoride. P5O10 is pentaphosphorus decoxide. Okay, and now we go the other direction, and the other direction is even easier. So first we look at exactly what's written here, nitrogen. So nitrogen is represented by an N. We've got oxide, and we have a di out front. So di tells us 2, oxide tells us oxygen, O2. No crossing charges, no Roman numerals, none of that will ever pop up for any of these questions. You just read exactly what's given to you in the name. Trisilicone heptaiodide. Again, let me draw some little dividers here so we can tell where they start and end. Trisilicone, silicone is Si, tri means 3. Heptaiodide, that's a little bit weird of a way of saying it, a name for something, but it's kind of got that like 3 vowel piece in there. But hepta is 7, iodide means iodine, so it'll be I7. And then for our last one, sulfur is S, hexa means 6, and fluoride is F. SF6. So again, no crossing charges, no Roman numerals, no anything like that. Molecular compounds are way easier than their ionic counterparts. They are definitely going to be your favorites whenever you can find them on the naming worksheets. In the meantime, though, this has been Mr. Diamond. If you have any questions about this, please let me know. Otherwise, have a great rest of your day, everybody.